So this chapter, the first three sections, we're going to be looking at solving systems of equations. And we're going to learn three different ways we can do that. Then we will look at graphing inequalities in two variables, and then solving systems of inequalities. So 4 out of our 5 sections involve doing the things we will be doing today. So what does it mean to solve systems of equations? You can see here I've got 2 equations. These are both linear equations because they're in the form y equals mx plus b. So if I graph this, it's a line. If I graph this, it's a separate line. So a system of equations means I'm looking for a point that makes both equations true at the same time. So let me give you an example of one that we can do probably in our heads. If I told you x plus y equals 10 and x minus y equals 0, can you think of a point that makes both equations true at the same time?
Yes.
What? It's a point. So a point needs to be an x, comma, y. So if x and y were both 5, x plus y is 10, because 5 plus 5 is 10, but 5 minus 5 is 0. So what this means is 5 is my solution to the system of equations. It makes both of them true at the same time. Does that make decent enough sense for what it is we're trying to accomplish? So we're going to be doing it with stuff that is not as easy to do in our heads, right? Like, can you tell me what makes both of these true at the same time? Negative 2 times something minus 4 is the same as a half times that something plus 6, right? I can't do this in my head, but what I do know is I can graph both of these. And if I'm looking for a point that makes them both true at the same time, I'm looking for a point that is shared by both lines, which will be the point they intersect. Okay? So here we go. I'm going to graph the first equation, which was y equals negative 2x minus 4. So you see why it's important. All these things we've already been doing, you've got to know how to do them now. This is already in slope-intercept form. So hopefully we know how to graph a line in slope-intercept form. The y-intercept is negative 4. So I plot my point at negative 4. Is everybody on board? I need to give you a second. That's what y'all can tell me, that kind of stuff, you know. You can say, hey, hold up. Hey, wait. Now, I have the y-intercept. I would use the slope to find more points on my graph. So the slope is negative 2, meaning I should go down 2, right 1. I can do this as many times as I want to. Because I do not draw good straight lines, I'm going to do it multiple times. Going down 2 and right 1 is the same thing as going up 2 and left 1. So I'm going to go up 2 and left 1 several times to give me this line. I don't draw negative slope lines very well. I don't draw any line very well, but specifically negative slope. Are there any questions about what we just did that I need to refresh you guys on how to graph something in slope-intercept form? Right here, this one's in slope-intercept form, but do we like 0.5 as the slope? I don't. I'd rather it be a fraction. So how could I write 0.5 as a fraction? 1/2. So I'm going to rewrite this as 1/2 x plus 6 because I would rather the slope be a fraction. Y-intercept is 6. 1, 2, 3, 4, 5, 6. Plot my point. Slope is 1/2. Up 1, right 2, up 1, right 2, up 1, right 2, up 1, right 2. I could also go down 1, left 2, down 1, left 2, down 1, left 2, down 1, left 2, down 1, left 2. And so here's the second line. So again, remember, what is it I'm trying to do? Find the point that makes both equations true at the same time, which would be this point. So what are the coordinates of that point? I'm going left 1, 2, 3, 4. Up 1, 2, 3, 4. So I've got a solution of -4, 4 to my system of equations. How could I be sure that this is the correct solution? If I plug it into both equations, it should work. This point should make both equations true. So let's just test it and see if we plug in -4 for x, do we get 4 for y? So I plug in -4. -2 times -4 is 8. 8 minus 4 is 4. So it works for the first one. 1/2 times -4 is -2. -2 plus 6 is 4. So it works for the second one. So -4, 4 makes both equations true at the same time. Cool, okay. I'll just be quiet and you guys go ahead. Do these two. You don't have anything to add? 5. Any questions about that one? All right, I'm going to pick up the pace a little bit as we need to. I need to find the solution to this system of equations by graphing. All right? Let's start with the bottom one. Yes. You guys know how to graph that?
Yes. If it says you divide. Which?
Not just, yeah.
Oh, I was talking about the.
Yeah, I'm with you. I knew you were. It's okay. Could I just rearrange this to put it in slope-intercept form?
Yes.
If I change the order of the terms? So what would that be if I change the order of the terms? -3x and a positive 5. Remember, when you change the terms around, the sign in front of the term has to stay with it. So the -3x, when it moves to the front, it's still -3x. The 5, when it moves to the back, is still positive 5. Everybody's good with that? Can we graph this? Y-intercept is 1, 2, 3, 4, 5. Slope is -3. Right 1, down 3. Right 1, down 3. Right 1, down 3. Right 1, down 3. Right 1, or up 3. Left 1. And that's all of them I can fit on my... Everybody's in? Everybody's good?
Yes.
You acted like you graphed the first one fine, so that's why I'm going to graph a little bit faster now, if nobody had questions. Now, this one is very not great for graphing. But I would want to put that in slope-intercept form if it were me, which means I want to get y by itself. So how can I get y by itself? I would subtract 15x from both sides. That makes this 5y equals, is that 10x? Oh, negative 15x plus 25? Because they're not like terms, so you can't combine them. Right? I was doing what I think you guys would do. And now, is the y by itself?
No.
It's being multiplied by 5, so I need to everything by 5. So y equals -3x plus 5. So this is the blue the top one. So let's graph this. I have a y-intercept at 5. Oy. I have a slope of -3. Down 3, right 1, down 3. Oh. 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 I am shocked and devastated.
Oh, wow.
So, what am I looking for graphically? I'm looking for the point that makes both equations true at the same time. Can you give me a point that makes both equations true at the same time?
Everyone.
Every one of them? So this point here makes them both... Oh, so
Everyone on the line.
everyone on the line. Every point on the line. 1, 2 is on both. So this has a solution at 1, 2.
0, 5.
And that's the only... No, there's more solutions. At 0, 5. So those are the only two... Oh.
No.
Yeah.
I would love nothing more than to list every point that makes them both true. Right? Because like you're not even including like this point, which is like what, 1 2/3 or something? I don't know. I'm just do you want to list all these points?
No, not really.
Me either. So guess how many solutions there are?
A bunch. Infinite.
Infinity.
There's infinitely many solutions.
Like Buzz Lightyear.
Okay, anyway. Can I
In-
draw the little thing?
We're going to get into Halloween.
Little-
Infinity? No.
What's the symbol for it?
That is the symbol for infinity, but the answer is not infinity.
Yep.
The answer is there are infinitely many points. Because remember, you're listing the points that make them both true. But there's a bunch of points that make them both true. It's not everywhere, as I pointed out with John's example, right? Because there are several points that don't make them both true. That make none of them true. But there are infinitely many that will make them both true. Buying that?
I'm buying it.
And again, you guys figured out, look at the equations. What gave me infinitely many solutions?
Same line.
When I had the same line with the same equation. Questions there? Let's work this one. Yikes. Not in slope-intercept form. Again. Why? Just make it easy on us. So I'm going to, I think the top one's easier to get into slope-intercept form. So what would I need to do to get this into slope-intercept form?
Y equals 2x plus 6.
If I added 2x to both sides, that makes that y equals 2x plus 6. Is everybody okay with that? Y-intercept is 6. 1, 2, 3, 4, 5, 6. Slope is 2. Up 2, right 1. Up 2, right 1. Down 2, left 1. Down 2, left 1. Down 2, left. 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 Down 2, left.
Lindsay, I'm so glad you guys did it.
Everybody's good with this?
What should we say?
Patty cake.
Can I do the next one? Okay, so I'm going to do this one in blue. It's not in slope-intercept form either. So I would start by adding 4x to both sides. That gives me 2y equals 4x plus 8. And now I need to divide everything by 2. Y equals 2x plus 4. So I can graph this. The y-intercept is 4. 1, 2, 3, 4. Plot your point. Slope is 2. Up 2, right 1. Up 2, right 1. Up 2, right 1. Down 2, left 1. Down 2, left. 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 Very good, very good, very good. Already hear some good words. So again, I'm looking for the point where the two lines intersect, which is nowhere. So what's the solution to my system of equations? There isn't a solution. Because there is no point they intersect.
I would say there is.
Can we draw the sign for this one?
Yes, this one does have a sign. That is no solution. But infinity meaning is not infinity.
Why not?
Does not mean the same thing.
It does in my mind.
Yeah, they don't. Hopefully, as we go, you'll.
Can I draw like?
No,
Infinite.
you're gonna write infinite,
And then.
many. No.
Oh, that's smart.
That's
Just do that.
No. Okay.
It means the same.
Why did we get no solution here?
Because they don't ever
They're
cross.
parallel.
They never cross because they're parallel. How do we know they're parallel? Same slope, different y-intercepts. All right, we learned about that when we talked about
Back in.
parallel lines and perpendicular lines. Problem. Monisha and Holly have 14 more days to finish reading the same novel for class. Monisha plans to read 9 pages each day, while Holly plans to read 20 pages each day. Assuming Holly and Monisha both maintain their reading plan, when will Holly catch up with Monisha, who will finish reading the novel first? So I need to write a system of equations to represent Holly and Monisha's reading pace. So let's start with writing for Monisha's pace. She's starting on page 96, and she is going to read 9 pages each day. So because she's reading 9 pages a day, that's a constant rate of change. She keeps growing by 9 each time. So does anybody have an idea of what the equation would be for Monisha? Y equals 9x plus 96. That would be correct. Slope of 9, y-intercept is 96. Okay, then the same for Holly's library. She's reading 20 pages a day, starting on page 6. So hers would be y equals 20x plus 6. So when I look at this, I do have 2 equations with 2 variables. So I could solve the system by graphing these. Do these look like fun to graph? A y-intercept of 96 with slopes of 9 or a slope of 20? It's not great. So, at least it's not great to do by hand. So since, oh my goodness, no way. Are you kidding? I need everybody to get a graphing calculator. Did everybody get their graphing calculator? Yes! All right, let's go. We can solve the systems of equations by graphing it in our graphing calculator. So I'm going to click y equals. I mean, it only took until October for me not to have to wait on everybody to go get a calculator.
Well, you know, half the time.
Oh, no! Oh, no!
I did get here a little.
Oh, it was so close. It was so close. Okay. Y equals. The first one, 9x plus 96.
How to put X in there?
It's the button right beside alpha. It says x comma t comma theta comma n. I need to record myself saying that. All right, and then the second one, y equals 20x plus 6. So I'm entering them both at the same time. Is everybody on board? If I click zoom and 6 to graph these,
I can't see it.
that's my point. Okay? All I can see part of a blue line, which is way on the left. You'll see that little piece of blue. And then I have the red line that looks fine. So those are my two lines. But can you see where they cross or where they intersect?
No.
So let's change the window to what we want it to be. So I'm clicking window. All right, let's think about what our variables represent. Let's start with x. What do the x's represent here?
Days.
The days. The days that they read. So what's the lowest x that makes any sense in this situation? 1 or even 0, right? If they read 0 more days, then we would be, Monisha would have read 96 pages, Holly would have read 6 pages, right? So 0 is the smallest x that makes sense. So do you see that first line that says X men? Is everybody there? X men? If you click window, it's not working?
Yes.
Okay. So the X men from the window, we want to make that be 0. So on X men from the window, I'm hitting 0. What about the X max? What's the maximum number of days we think it's going to take them to read? Well, I'm just doing quick math in my head. If Holly reads for 10 days, she would have read 200 pages and 6 more, which means she's not quite at 220, right? So she should be done on day 11. I don't really know. I'm going to put in 15. I feel like 15 is a good X max. I think that those should both be done in 15 days. Does that make sense to everyone? X scale, we'll leave it 1. Let's talk about the Y's. What do the Y's represent here?
What page are now?
Yeah, how many pages they've read in total, or what page they're on now. So what's the lowest page number that makes any sense? Page 0. What does it? We don't have negative pages. So let's put in 0 for the Y min. What about the Y max?
220.
220. I'm going to put in 225 just to make sure I can see everything happening at 220. Do I need to show you guys what my window looks like, or does everybody follow along? Do I need to post it? Everybody's good? All right, I'm going to click graph now. And it should change my graph to be between 0 and 225 on the Y's and 0 to 15 on the X's. Here's what my graph looks like, so everybody can see it. Do what yours looks like. Is everybody good? So the question was, first question, when will Holly catch up with Monisha? So where's that represented? Where did Holly catch Monisha? Remember, the Y's represent the number of pages that are read. So after 1 day, Holly was here and Monisha was here. After 2 days, Holly and Monisha. When did she catch her?
Day 8.
At the point of intersection, right? Wherever they meet, that's where they've read the same number of pages based on the day. So how could I find that point of intersection? Our calculator will do it for us. Is everyone ready?
Yes.
I click second, trace. That stands for calculate. Which of those categories do you think is what I'm looking for? 5, intersect. I'm looking for the point of intersection. I click enter. Now it's going to make you choose which 2 lines you're looking at. So just in case you have like 8 things graphed, you're selecting the 2 curves, is what they call them, that you're looking at. So the first curve, mine's on the blue one. That's good. Second curve, mine goes to the red one. That's good. And then give a guess. So if they met in multiple places, which would mean they were not lines, then you'd have to do the guess. For us, the guess does not matter. So I can click enter again on guess. And when I do, I get an intersection at 8.1818182.
What were you hitting like?
Second,
Well, I'm on the.
calc.
There's what you get.
Oh, I got it. She said click enter. I didn't know.
Gotcha.
Things about that.
No, it's gonna be.
There's another one.
Did everybody get 8.1818182 for the x? Do I need to help someone? Everybody got it? So the point of intersection, let's go ahead and write that down, is 8.1818182, comma, 169.63636 is my xi values. So on what day, let's answer the question now. Assume they both maintain their plan. On what day or when will Holly catch Monisha? So how many days did it take Holly to catch Monisha? It did not. It took 8.18 days. Which would mean it was day 9. Because think about it. If this x value is at 8.18, that means 8 is like right here to the left. So what happened on day 8? She's still slightly below. What happened on day 9? She passed her, right? So to catch her, she had to read more than 8 days. Does that make sense to everyone? 8.18 days means she read for 9 days. Okay? And so she caught her and passed her. And so who will finish reading the novel first? The red one, which was Holly. Because she stays ahead of Monisha. And why? Person 9? Is there a person 9 in the building? Okay. So, what changed when Monisha read 10 pages a day?
It still took 9 days.
Yeah. So it was still 9 days. But it was a lot nicer 9 day, right? Like the number. The point of intersection should have been at 9.186. And it was exactly 9.186. You can. How will Holly still finish the novel first? Yes. Because they weren't finished after 9 days, right? They were at only 186. And so Holly will pass her after the 9th day and stay ahead. I'm good with that. Y'all good with that? Okay. Now let's do this one. Solve this system of equations. Just watch very quickly as I do this on our graphing paper. These are both in slope-intercept form, which is good. That makes it easier to graph. My y-intercept is at -3. Slope is 2. I rise 2, I run 1. Rise 2, run 1. Rise 2, run 1. Rise 2, run 1. Or I could go down 2, left 1. Down 2, left. Down 2, left. I'm graphing my best line I possibly can. I'm so proud of myself so far.
That looks really bad.
Shut up. Next, y, I'm just kidding. I was just kidding, by the way. Y equals -5x plus 6. I have a y-intercept of 6. There's no video evidence of me saying it. I know, I'm going to have to delete my video. I could go up and left, but that's going to put me off as well. Okay, so I'm somewhere here. Oh, yikes. I started curving. That was bad.
Why don't you do one straight line? Why are you doing it? Well, I thought.
Because not everybody can just draw one.
Because I'm trying to get as good as possible for this one. I do better when I do it that way instead of just drawing a straight line. So do they intersect? Yes, there's one solution. Yes, where's that solution? Here. What is it?
I ain't help, but you bring it up. One negative one.
Is it exactly 1 negative 1?
I can't tell.
Them lines are something there.
I can tell. No, it's not. It's like 1.2 and like negative 0.8. Does that sound good though as our answer? Like if because how did we check? If I plugged in 1.2 here, would I get negative 0.8 out? I don't know, but I don't really want to multiply that. That sounds awful. So here's the point of this example. When you solve systems of equations by graphing, sometimes it's ugly. Yeah? Yeah. It's not great. And so how am I supposed to know exactly the point of intersection? I have to do this in a calculator. I can't do it any other way. If I had to graph it. So I'm going to type in these two equations. 2x minus 3 for y1. And negative 5x plus 6 for y2. I'm going to click zoom 6 to graph. It's basically what I drew, except my colors are backwards from my calculator's colors. Oh, you're not there yet? Sorry. Slow down, slow down, slow down. Algebra 1, algebra 1, algebra 1, algebra 1. Let me show you what it looks like.
I got like 1.2.
Well, I've not done I just want to make sure everybody's graph look right, correct. Here's what I got when I click zoom 6. So to find the point of intersection, can I do that part yet?
Yes.
Second, calc, intersect. First curve, second curve, guess. Second trace. The little thing above trace is calculate. You see it? So this is at point of intersection is at 1.2857. 1.
Wait, how do you get
4. 2857. 142857.
How do I make it guess?
You did second calc. Guess, just click enter. And it will tell you.
Intersect.
Wait.
Yes.
How do you make it tell you?
And then press guess.
Second trace. I'm going to choose a point of intersection, which is 5. Select the first curve, second curve, intersect, enter. Yeah, one more time.
I got 1 point.
Yes.
What's wrong there?
Mine's. Something's wrong with it.
Wait, I think I had it on.
That's right. You just got to click enter one more time. It's saying, where should I guess? I don't know. That's good. Yeah. I think I wrote mine down wrong. 1.2857. 142857. 142857. 142857. 142857, comma, negative 0.42857. 428571, 428571, 42857, repeating. You guys know your repeating decimal for the 7th? Nothing. I'll explain it in a second. Did everybody get these answers? Everybody's good with that? All you need to know is it's like at 1.29, negative 0.43, right? You don't have to know all this repeating decimal junk. But it's cool if you do, so I'm going to show you in a second. Anyways, try this one. What's repeating?
1.630.
Which part's repeating?
630.
Okay. And
And then 4.88.
these are correct. You probably have the wrong equations entered. Did you click y equals?
Yes.
Okay, let's look at it.
Right there.
Did you forget an x again? Okay. Oh, you don't.
Jay,
This is
wait.
three.
It's right at
No,
three.
you have to click enter one more time and guess. No, give you the actual point. That's where. Is everybody good with this?